Yeah, all right. Thank you for the kind introduction, and thank you for joining the session. Reuse and material passports fits very well because in this presentation we are focusing on how to reuse that kind of concrete element components. And when we want to reuse them, we need some data about them. So we store them in inspection certificates, as you can see here, which can be part of a material passport. Yeah, my name is Lukas Guntermann, and I did this research with my colleagues, Nina Krautgartner, Hendrik Zielonka, Philipp Hagedorn, who's also here, Peter Mark, and Markus König at Ruhr University of Bochum in Germany. So the overall goal is to reuse reinforced concrete elements. This comes from the European waste hierarchy that clearly says that prevention of waste is the highest goal. After this, there comes the reuse of elements, which is not the same as recycling, where the concrete gets crushed. So we aim for that reuse. And to do so, we need some data, for example, from pre-demolition audits, according to the DIN spec we have in Germany, and also data from element-specific inspections in lab, which we're focusing today on. And the challenge here is the link between this inspection data and the inspection certificates to the BIM model. So our research question is how to extract and transfer inspection data from inspection certificates to BIM models for a continuous flow of information. So we developed this data concept, starting with the deconstruction and the dismantling of the components, as you can see here. Then we generate the inspection data, which can be stored in an inspection certificate as a PDF. Then we want to digitize it and store the data in a more meaningful way. You will see this in the following slides. Then there comes the planning with the reuse components, the new building, and the life cycle starts again. Our methodology for this work first started with the definition of the parameter set we need for these inspection certificates. We derived them by literature studies, and then we needed a data structure for it. So we created a sample PDF inspection certificate and also the zero ontology for storing these parameters, which is one of the main contributions of this work. And yeah, to validate and demonstrate the whole approach, we did a case study. So yeah, first we evaluated the ontology with competency questions, and then there was the case study with a small OCR reading of the inspection certificates with a link of the PDF inspection certificate to the BIM model via information containers. And we've also shown how to query the data from the RDF-based model. So to take a look on our data structure, we organized it in 3 categories. So the first section is the general element and project information. The second section is the condition assessment. And the third section is the durability and remaining service life section. And yeah, we have a couple of parameters here. For example, in the middle section, we have mechanical properties such as the concrete compressive strength. And yeah, you also can see the references here. Our data structure of the zero ontology, so the concrete element reuse ontology, is shown here. So we built it on some existing ontologies. So we used the ISOProps ontology for the property management, the metadata for ing ontology for the process description, the QUDT ontology to store physical quantities, and also the BOT ontology, the BEO ontology, and the BPO ontology for the BIM context. Here you can see how the data is transformed from the inspection certificate into the ontology. So yeah, we have the parameter here, the concrete compressive strength, which is stored as a property according to metadata for ing. This parameter is determined by some investigation method. In this case, it's a rebound hammer, which is also stored with the metadata for ing ontology. And yeah, of course, we have some value and unit, which are stored as numerical values, with according unit. We evaluated this approach with competency questions, with 2. So the first was, can all general element information and project information be queried in the model, which is shown here. And the second one was about the condition assessment and the durability and remaining service life information. Here you can see how it looks like. We did this all in the ICDD platform of our chair. You can see here the competency question in the middle and the resulting data table at the bottom with all the information, the general and project information. In our case study, we've shown the information extraction with optical character recognition. So we built a small Python script to extract the data from the PDF inspection certificates and store them into the ontology in the turtle file. So to come to a conclusion and the outlook, the main contribution of this work is the zero ontology, which we have already published. We also modeled the information flow for concrete element reuse during its life cycle. We did a small OCR extraction of inspection data from from inspection certificates to BIM models. And we also can demonstrate the linkage in the ICDD platform of PDF inspection certificates and the model. Of course, this research has some limitations. So first, I have to mention the OCR accuracy and reproducibility. And there are also some new EU standards from this year regarding digital product passports. So we have to align it in future a little bit with our work. And yeah, we also did some tests or planning some tests with the new IFC5 format to sign documents and sign inspection data. And yeah, we also plan an expansion and a further validation of the zero ontology. Yeah, here are the references of today's presentation and the funding information. And yeah, thank you for your attention, and I'm here for your questions.